In this video, we will derive section formula to find the coordinates of the point which divides a line segment joining two given points in a given ratio. That means when you take a line segment, for example, AB is the line segment, okay, that divides, P is the point that divides the line segment in the ratio M1 and M2, okay. So, you will be finding the coordinates of the point. So, this coordinates of the points you will be finding. Okay. This coordinate points which divides a line segment joining two given points in the given ratio. So, ratio will be given. The coordinates of these 2 points will be given. You will be finding the value of these coordinates. That is x comma y you will be finding. Okay. Now, you take like this, you take x-axis and y-axis. In this you have points, that AB point I am drawing it here. Okay, so A is, you take it as x1 and y1. Okay, then B point is x2 comma y2. Then a point P is there, that is x comma y. P x comma y. So this P is dividing this line segment internally in the ratio M1 is to M2. So this point P is dividing the line segment AB internally in the ratio. The point is inside the line. So internally it is dividing the line segment in the ratio M1 is to M2. So this coordinate point x comma y, that is only, if we find the value of this x comma y, that is the section formula. Okay, so if all other values are given, you can find, that is M1, M2 will be given, x coordinate, y coordinate of A and B will be given, then you will find the coordinates of x comma y. P x comma y you will find. That is the section formula. Okay, so now you draw a perpendicular line. You draw a perpendicular line from A, from P and from B that touches the x-axis. Okay, you are drawing a perpendicular line from A, from P and from B to the x-axis. So, you will get a perpendicular line. So, you name that as, this is the origin. Okay, this is the origin. So, you name this as M. Sorry, M is already there. So, you will give S, T, R. Okay, so this AS is perpendicular to x-axis, PT is perpendicular to x-axis and BR is perpendicular to x-axis. Now, you draw another perpendicular to y-axis. Name that as C and D. Name that point as C and D. That is perpendicular to y-axis. So, AC is perpendicular to PT and PD is perpendicular to DR. So, now you will get two triangles. Now, you will get two triangles. So, that will be similar. Why? How it will be similar? So, these two are parallel. So, you will get AA similarity. So, using that AA similarity, you can say that these two triangles are similar. So, which two triangles are similar? APC is similar to PBD. So, these two triangles are similar. So, if it is similar, if the triangles are similar, we can compare the ratios of the sides. The ratios of the sides will be equal. So, this side and this side. So, two triangles are there, these two sides, that is AP by this side, AP by PB. That side will be, those two ratios will be equal, is equal to AC by PD. AC by PD. Then CP by DB. So, three sides of the triangle, since it is similar, these two triangles are similar under AA similarity. all the sides are in the same ratio, so you can write like this. Okay, AP by PB. So AP, so what is the length of AP given already? We have taken that as the length as M1 by, for PB we have taken it as M2. So M1 by M2 is equal to AC, AC length. So if you take this AC, so AC, this length is equal to ST. Okay, the previous video we derived the distance formula, isn't it? There I told you how to take the length of this. So the length of this one will be OT minus OS. So OT, what is the value of this OT? OT length is X. So O, this point is X. So OT is X. X minus OS. OS length is X1. X minus X1. This is AC. Okay, so here instead of this AC, we will substitute X minus X1 by PD. The same way, this PD length and this TR length is equal. PD is equal to TR. So how will you take this TR? TR is OR minus OT. Okay, OR minus OT. What is OR length? OR length is X2 minus OT length. OT length is X. So you substitute this value here. So PD is X2 minus X. Same way, CP. So this length is CP. The same way, if you take the length of CP, if you take the length of CP, the same way you can find length of CP. Length of CP is TP minus TC. This full length TP minus TC, you will get the length of CP. So what is TP length? TP length is Y. Y minus TC length is Y1. Then same way, so this CP value you substitute Y minus Y1 by DB. DB is this one. So DB is equal to RB minus RD. So RB is, what is the length of RB? Y2 minus RD. RD length is Y. Y2 minus Y. Okay, so substitute that here. Y2 minus Y. Okay, so all these three ratios are equal. So now I am equating the first two. Okay, that is M1 by M2 is equal to X minus X1 by X2 minus X. Now I am cross multiplying this. Okay, cross multiplying this. So when I cross multiply this, I will get M1x2, okay, M1x2 minus M1x is equal to M2x minus M2x1. Okay, now you take the x value to one side, the other things you take to the other side. M1x2, this one I am bringing to the other side. So plus M2x1 is equal to, this M2x is there as it is. Keep it as it is in the right hand side. Bring this to the other side plus M1x. Okay, so what you will get? M1x2 plus M2x1 by, you can take this x common, balance you will get it as M2 plus M1. This is the value of x. This is the value of x coordinate. Okay, so the same way you can find the y coordinate also. So the same way, the same method you can find y coordinate also. So you will get x coordinate as M1x2 plus M2x1 by M1 plus M2 and M1y2 plus M2y1 by M1 plus M2. So this is called the section formula. Understood? So when all the values, that is m1, m2, x1, x2, y1, y2, all these, if all these values are given, then you can find the section formula. So this is the general form of section formula. That is, this is the p coordinate. Here you have no p, x comma y. So x value is this one. When you simplify, when you substitute all these things, you will get x coordinate. And when you substitute all these things, you will get the y coordinate. Understood? Thank you.